everyone. In today's class, we will discuss about the basic Turing machine model and a representation of Turing machine and language, what are the language accepted by the Turing machines. So, already we have seen the finite automata machine and push down automata, and this is the another is Turing machine. This is the different from the finite automata and like the push down automata. See what are these how to function, how this Turing machine model and what are the tuples are there like finite automata and PDA and how it is in tape, how it is working, we will go through all this. So, this Turing machine is invented by Alan Turing. So, here is the some different like finite tape. In finite automata, we have a tape. In that tape, we have input alphabet symbol, input alphabet, and that input alphabet only we can read it. We only read the input alphabet. But here in Turing machine, we can write also. There is a option we have to write on the tape. But in finite automata, if you are talking about the push down automata, there is only you have to read it. But in Turing machine, we can write also on the tape. So, also in finite automata, your tape is moving from one direction from left to right. If you will go through the DFA and NFA, you will see that also PDA like that your input alphabet read from left to right and your head will be moved from left to right. But here is the tape is infinite, you can move from left direction, you can move from right direction, any direction you can move, and here it is infinite tape and it is read write possible. And in push down automata, we have read the input alphabet and we are using the stack. But here is the tape symbol, see here what it is written, a tape divided into cell, tape is divided into cells. So, each tape already same thing in finite automata, we divided into cells and one next to other. So, like input alphabet will be stored in a cell in that is called tape, and each cell consists of a symbol. You see this is the each cell consists of a symbol from a some finite alphabet. So, your whatever input you have to take input string that is finite, and the alphabet consists special blank symbol. Blank symbol means wherever input, then at the left end and right end there will be a blank symbol. So, that then one or more other symbol, the tape is assumed to be arbitrarily extendable. The tape will be extendable, we can move to left and move to right, left and right both direction we can move. So, that Turing machine always applied with as much tape as needed. So, how much tape we needed, that will be extended. So, in both side we have blank. So, what you have to do, in blank will be in blank also we can write something, you read in blank and write something there, and your input alphabet will be means tape will be extended. So, that have not written before. So, this blank symbol, in some models tape has left mark and special symbol and tape extend identically extensible to the right. So, this is the Turing machine tape. I will talk about the only tape. So, another is head. Also in finite automata we have some head, that head point to a input alphabet and read from left to right. But here also head, a head is there, head that can read and write symbol on the tape and move tape both left and right one. Okay, and only one cell at a time, only one cell at a time. So, what you have to do, in your tape your head will be point a input alphabet, you can read it. If you want to replace that, write something there, then you can write there and you can move either left or right, but that will be modified only one input alphabet at a time. So, and state register to state of the Turing machines only finitely many. Among these, special start state with means there is a state register which is the start state, it will store and then it will continue, then it will compute and reach in the acceptable state, final state, this will be accepted. So, this is the Turing machine concepts. So, how this is different from finite automata and push down automata. In finite automata we can read only in the tape, but in push down automata also we can have read, but here we can read and write, both we can do. And here also tape, you can, your input tape can be extendable infinitely as much you want. So, here how this is model, see here input tape, and this is a tape and this is the tape head, you can say this is the tape head, this is a finite control tape head, and you read, suppose we have read this B. So, read B and either you can move to left or move to right. In this way you can move from left or right, or you want to replace this B. If after that you want to replace this B as a capital B, also you can replace, you can write and modify that small b to capital B and move your tape head either left or right. And some advanced is there, also sometime we have to stay there, that will be come in variant of Turing machine. We have left right move, and some Turing machine is there, you have to stay there, no need to move left or right, that will be come in variant of Turing machine, we will go to later on that. So, this one is concept of the Turing machines. So, see how this step will be, I will explain the tuples, then after how we will go to right on the tape, how this will be left move, right move, like that we will check it. So, now the representation of Turing machine. So, here is the Turing machine having 7 tuples. So, you can have capital Q and input alphabet, and this is a tau, tau is the, this is tau, tau is the tape input alphabet, is the tape alphabet, and del is the transition function. So, this is the del is the transition functions. So, sigma is the input alphabet, and you see Q0 is the initial state and B is the blank, B is the blank, means there is empty, means both side blank is there. When you will keep your input on the tape, in both side it will be blank. So, now you this and F is the final states, where after computing your string, then you have to reach in the final state, then your string is accepted. So, here we have written the transition functions. What is the transition function here? See here, what is the transition functions? So, you are in a state Q, then you have to take a tape input alphabet, and that then after you have to go to another state, and there is also tape, either you want to keep the same symbol whatever was there in tape, or you want to modify that tape and write something there. That is why tape symbol is there, tape is input is symbol is there, then go to the next state, and here is the left shift and this is the right shift. You can have left shift or right shift. Suppose I will take an example here, you see here, suppose this is Q0, I am not drawing the full diagram, just taking a transition. You can check here, this is A, then you have to A, then this is A R, this is A and A R. Then after we have B input, then B, B R. So, then after you have this is Q1, Q1, and this is A, A R. Then this is B, B R. Then after, if your blank is there, after that I have written B and this is B, then right, then this is and QF. So, you have to, this QF is the final state, QF is the final state, you can say this is a accepted state. So, here everything is clear. Now, you have capital Q, I am writing all the see here, capital Q is Q0 and Q1. So, tape input alphabet, we can say tape input alphabet is, we are taking here A and B, another is blank. You can take blank as a tape input alphabet, consider as a blank, and input alphabet is only A B. Here is the only A B transition, and Q0 is the initial state. You can say this is the Q0 is initial state Q0. Now B is the blank symbol, F is the final state. So F is QF. So very important is transition function. Very important is transition function. How to this transition function work? How this transition function work? See here, I am writing the transition function. What is the Q0? When you are taking input A, then your tape remains same symbol and move to right, move to right. So here you can say like that Q0, I am writing here all the transition. So here is the Q0, then input is A, then what you have to do? Same thing, it will be go to Q0 and input is A, tape input is A and move right. This is the transition function. So it is remains same, whatever A is there, A remains same, no need to modify, no need to modify this, no need to modify. So here another transition is there, you see here del Q0 and A, this is B, then this is Q1 and B, this is right. So now another transition function is there, Q1 A and this is Q1, this is A, then move right, move right. Then Q1 B, Q1, this is B R. Now you have Q1 blank, then this is QF, QF blank right. So you have to, this is the accepted state, this is the QF is the accepted state. These transitions are given. So whatever diagram is here, and same thing here I have written the transition function, but here what happened, only I read all the input and move right. I did not replace, I did not write anything on the input tape. I did not write anything in the input tape. You see whatever it was there, input tape is A and A remains same, and B, B remains same, and A remains same, and here is the B, B was there and blank blanks. So I did not write anything on the tape. So you can say this is a regular language. What will be there? This this is a substring of B. Every string must have a B. This is the accepted by this diagram. If you will check it, now you have to take a input alphabet. So I will take a tape and keep some symbol there. We will go to the next page and how this is working, I will show you. So we have drawn the diagram, see here we have drawn the diagram. What are the diagram? Q0 and this is A, A2, A, R, and we have written this is B, B2, B, R. So now this is Q1 and this is A2, A, R and B2, B, R, and here is the blank, this is blank and this is blank and this is R and this is QF, QF is the final state. So we did same diagram whatever I took, same diagram I did here. So now you take a input tape, this is the input tape. So I have taken a input tape is, this is, suppose we will take example A, B, B. This is the string we have to, this is the string we have to take, this is string A, B, B. So now we have A, B and B, and both side you can assume this is blank and this is blank, you can write or you can make it empty. So, this is blank. So, both side is blank, you consider as a blank, otherwise you can write here capital B as a, we have considered as a blank this one. So, now your tape head is now Q0 state, then tape head point to A. Now, tape head point to Q0A. Now, you check when you are taking Q0 to A, what you are doing, what it is doing? It is again come back to Q0 and whatever tape input that will be remain same. So, we already I told you what the transition function is there. What are the transition function? Transition function is saying that capital Q and this is tape input, then after that capital Q and this is tape input, then L or right, L comma R. So, either you have to move left or we have to move right. So, here one transition is given that Q0 input A and move Q same Q0 and tape input will be remain same, whatever A was there, A remains same and move right, move right. So, it will be, what will be there? You see here, this is A, now B and this is B and now Q0 point to B, clear now. So, Q0 point to B. So, when it is B, now you check when Q0 input is B and goes to Q1 and your input tape remains same, whatever B was there that B remains same, just move right. So, now we have this is Q A B and this is B, then Q1, Q1 is the head, now Q1. Now, Q1, now we go to the Q1, in Q1 we have B input, we have B input and again you see in when you are taking input as a B, that B remains same and move to right direction, move to right direction. So, what will be there? You see this is the, you can write both side blank. So, now A, B and this is B and here is the blank. So, now Q1 point to blank, when Q1 point to blank, then we will go to the final state. So, here it is same thing, both side will be blank. So, you can write here this is A, B and B and this is also blank and this is blank and here is the final state QF. You can next blank, after that also blank will be there, that is why we write a single blank, no need to write here blank, then after that you go to the QF. So, here A B B is accepted, A B B is accepted. So, you can say whatever regular language also we can have, we will go later what are the language will be accepted by this Turing machine acceptance, which language will be accepted by the Turing machines, how it is be accepted. Now, I just gave an example how this Turing machine work, but in this example I did not write anything on the tape, just I read the input alphabet and move right. So, I have also I have not written any left side left move, because it is a just you see you have written this one, this language is what is the, here the diagram all string have a substring B, So, if a string having B as a substring, this will be accepted and you can say this can be accepted by the finite automata. That is why here no need to move anywhere, just read the input and go right, and when we will find the blank and go to the final state. We will do more numericals, just I am explaining what are the tuples and how this is work. So, when we will be doing more numerical, that time we will be check it. So, this is the right. So, similarly you can move the left direction. So, similarly we can replace the character by writing something. So, now see how to replace. So, I am writing another transition here. This is Q, now you see Q 0 and this is A, and we have written this is Q 1 and this is B, and move right. So, here what is that? If your tape is like this, input is A, just I am taking an example, input is A, now Q 0. So, like that what will be there? Then after this it will be Q 0 to A will be replaced to B, then Q 1 will be point to this. So, this transition is like that. When you have input A, you read input and replace to B, you write on the tape. Here we write on the tape, this is right. So, A is replaced and B is right on the tape and move to right. You can have remove, this move is right. Similarly, we can have left direction, you can have right something, like that this Turing machine work. So, we will do more example. So, language acceptability of Turing machine. What kind of language is accepted by the Turing machine? So, already we have last lecture we have checked that some language that not that using pumping llama, we prove that some language is not context free. For that we do not have the push down automata, So, for that we have to choose for the Turing machine. So, Turing machine is the, you can say Turing machine is the higher machine that can be, if you see context sensitive language, here is the context sensitive language. You see context free language, if some language is not in context free, we cannot have push down automata. So, what will happen? All the language, either regular language or context free language or context free sensitive language, all language will be accepted by the Turing machine. So, Turing machine is the higher machine. So, any context sensitive language is there, that is also accepted by the Turing machine. If context free is there, that can have push down automata also, that can be accepted by the Turing machine, because this Venn diagram you see, this is the higher, this is, you can say this is a finite automata and this is a push down automata and this is a Turing machine. This you can say halting Turing machine. I will discuss later on what is the recursive enumerator of halting Turing machine and Turing machine. So, this Turing machine is the higher machine and it is greater than the finite automata and PDA. So, all the regular language, context free language and context sensitive language, or you can say recursive language, that can be accepted by the Turing machines. So, here we prove that using pumping llama, we prove those languages are not context free, that cannot be accepted by push down automata. We must have to go for the higher machine, that is Turing machine. But if a finite automata is there, the regular language is there, we can design in finite automata, we can design in push down automata, we can design Turing machine also. But if context sensitive language is there, or more than that recursive language is there, for that we do not have push down automata, do not have finite automata. So, here I have written some question that came in GATE 2021 exam. So, suppose L is a regular language, L1 is a regular language, L2 is a context free language. Who is one of the following language not necessarily context free? So, it is given that L1 intersection L2, L1 so, these 4 option is there, we have to check which one is not necessarily context free. So, here see the diagram, this is the regular language, then after you have context free language. Okay. So, if both intersection first one is saying that intersection of L1 intersection L2 that can be context free, because either union or intersection always will be the higher language, either union or intersection always will be higher language. So, this is a CFL. So, now concatenation also same thing, this can be a CFL. So, now L1 union L2 this can be CFL. I told already either union or intersection always will be the higher language. So, regular language union CFL or regular language intersection CFL, that both will be in case of CFL, result will be CFL. So, there is no, you cannot say this one is not necessarily CFL, L1 minus L2, because L1 is a regular language. From regular language you have to subtract the context free language, that is not necessarily context free, and this is context free, this is context free, this is context free. So, here option C is right, right option, option C is right option. So, this question came in 2021 in GATE exam. So, you can see another question is there, which of the following Turing machine does not consist of. So, already we have checked there, we have Turing machine input tape, we have an head and we have also state of register. So, none of the mentions. So, everything is there, all things are present in the everything is there, which one of the following two does not consist of. So, these all are present in Turing machine. So, this is the none of the option is, this is, you can say this is the right option. It is negative, asking not consist of. So, these are question may be come in your exam, like in competitive exam some Turing machine question will be there. So, you can handle like this. So, these are reference you can give to the that book, which one is the Aho Ullman and Michael Sipser. So, thank you.